Hi everyone. So we need to finish up our lesson from yesterday on absolute value, and I'm kind of picking up here. I know this may be a repeat for some of you. Fourth hour, you got a little bit further than second hour did, but that's okay. Won't hurt you to see it twice. So when we're working with absolute value and inequalities, you always end up in one of these two situations. Either the absolute value is smaller than some number, and those are the cases where you're keeping the numbers close to zero, okay? You want them to be within a certain distance, okay? And so those are the ones where if you look at them on a number line, the shading's always going to be kind of between two different numbers because that's where the distance is less than that given number. Or you can have the absolute value be bigger than a number, and that's where you're saying, like, stay at least 3 units away from me, or stay at least 5 units away from 0, something like that. And that's where we start at a certain number and then go out to the ends of the number line. Okay? When it's one of these, which is one of the one of the intersection problems, if you remember when we talked about unions and intersections back in 5.1, when it's shaded in between two numbers, you can write your inequalities as x is less than whatever this number is that you're looking for. So whatever number would be right here, x is less than that number, and x is greater than the negative version of that number. Okay, and so your actual range of numbers falls somewhere in between, and that's what and does for you, is it says you've got to fit both of these criteria at the same time, and so you've got to be these numbers in between the two endpoints. When you have absolute value being greater than a number, you can write your inequalities as, starting at this number, whatever that magic number is, going to the right, because that's getting bigger, so x is greater than that number, or starting at the same number but negative and then moving to the left, so that would be less than. So x is less than the negative number, or x is greater than the positive number. This one has to be an or because you can't be on both arrows at the same time. And so that helps you kind of set up your two different inequalities that you're going to be solving. It might be helpful to notice that the positive one, okay, wherever you're looking at the positive version of the number, the inequality symbol always matches what it was in the original problem. So if it's an absolute value is less than problem, then the first inequality is going to be x is less than the number. If it's a greater than problem, then x is going to be greater than the number. And then the negative one is always going to be the opposite. So over here, this was less than, so then when my negative number, I would use a greater than symbol. Over here, this started as greater than, so with my negative number, I would use a less than symbol. So let me show you kind of how this works. If we look at the absolute value of x minus 6 is less than or equal to 3, and I know we did this yesterday, but it was a little rushed. I first have to think about which scenario am I dealing with, and because this is a less than problem, it's going to be one of these, okay, where my numbers are going to be within a certain range. So just to kind of keep that in mind, I'm going to sketch this up here, is I know my answers are going to end up looking like this. It's going to be between two numbers, okay? And that means I'm going to write two different inequalities. I'm going to write x minus 6 is less than or equal to 3, okay? And that covers sort of from here backwards, okay? So I'm saying that it needs to be less than 3, and x minus 6 has to be greater than or equal to negative 3, because I want to say, all right, but we have to stop here and go the other way, and that's how I get my values in between. Okay? So less than told me that this is going to be a shading in between type problem, which means that I'm going to be less than this number and greater than the negative version of this number. Now I'm just going to solve these two inequalities separately. So if I add 6 to both sides, I'm going to have x is less than or equal to 9, and add 6 and add 6. Okay, x is greater than or equal to 3. So when you think about what that looks like on a number line, let me just get a number line down here for us. Here's 9. Here's 3. the numbers that are less than or equal to 9 and greater than or equal to 3 are going to be all these numbers in between. And they have equal bars, so I'm going to use a closed circle, and I'm going to shade everything in between. Okay? And just so you can see how this works, let's pick a number that would fall somewhere in this range. So what's in there? 5, right? 5 is between 3 and 9. So if I put 5 back up into my original equation, I would have the absolute value of 5 minus 6 is less than or equal to 3. And what I'm really saying here is that whatever the answer is to this it is less than 3 spaces away from 0. Well, 5 minus 6 is negative 1, so the absolute value of negative 1 is less than or equal to 3. Negative 1 is less than 3 spaces away from 0. Okay? So you could pick any number in here and do that same thing, and it would always come out to be a number that's within 3 spaces of 0. Okay, and that's what that's really telling you there. Okay, let's do a similar one. Our next example here looks awfully similar, except this time it's a greater than. X minus 6 is greater than or equal to 3. And so because this is a greater than, this is going to be one of the like get away from me ones, where you've got a number here and a number here, and you're shading out to the outer ends of the arrows. Okay? So one of your inequalities is going to read, just like the problem does, x minus 6 is greater than or equal to 3. And that sort of takes care of this arrow, okay, the numbers that are bigger than 3. But to take care of this arrow, we're going to say or, and again, this is an or because you've got the two arrows pointing in opposite directions. X minus 6 could be less than, because notice this one is moving in the less than direction, less than or equal to negative 3, because negative 3 is also 3 spaces away from 0. So when I solve this time, I'm going to have x is greater than 9, greater than or equal to 9, or x is less than or equal to 3. Now, you can't be greater than 9 and less than 3 at the same time. So when I go to put this one on a number line, here's my 9, here's my 3. It's going to be two different arrowheads. I'm going to have one starting at 9 going to the right, one starting at 3 and going to the left. And I could pick any number on either one of those arrows and plug it in, and it would give me a value that is less than 3 spaces away from 0. So again, that's what you're really trying to find here, is give me numbers where if I subtract 6 from the number, I'm going to land somewhere that's more than 3 spaces away from 0. Okay, and anything on either one of these arrows would work. Okay, so let's jump in and just do some sort of straight up solving here. And our number lines are going to be pretty bare bones. Okay, don't feel like you have to get real fancy here. So with this first one, absolute value of 2x plus 1 is less than 5. I would start this as saying 2x plus 1 could be less than 5. Whoops, didn't mean to do that. Equals there. And the less than ones are the ones where you're shading between the two numbers because you're keeping your distance small. You're saying you need to stay within this range. Those are the and problems. 2x plus 1 would also need to be bigger than negative 5. See how that works? So I always set up the first one looking exactly like the problem, and the second one with the inequality flipped and the negative sign there. Okay, because the negative numbers run backwards from the positive numbers. Just to solve this real quick, let's see, I would subtract 1 from each side, so I'd have 2x is less than 4, which would mean x is less than 2. And on this one, if I subtract 1, 2x is greater than negative 6, which means x is greater than negative 3. Okay? And then on a number line, it's off to the side here somewhere, here's my 2, here's my negative 3, and I want to shade the numbers that are bigger than 2. I'm sorry, less than 2, and greater than negative 3. So that would be everything between the two. Now this time I don't have equal bars, so I just do an open circle and an open circle and shade everything in between. Okay, again, sorry that's kind of messy and tiny. We're running a little bit short on room here. All right, on this next example, notice on this one, I'm not starting with just plain old absolute value over here on the left. I have this extra plus 2 here. Before I split and write my two separate problems, I do need to move that 2 over to the other side. So I'm going to start by doing minus 2 and minus 2. Okay, so this is still absolute value of negative 3x minus 6 is greater than or equal to 12. Okay, and now I can split and write my two different inequalities. So I can say negative 3x minus 6 is greater than or equal to 12. And a greater than absolute value are the arrows pointing out in the opposite directions, where you're saying you need to stay at least this far away from 0. So those are the or problems. Negative 3x minus 6 is less than or equal to negative 12. Okay, and then I'm going to solve these separately here. Again, I've shorted myself on some space here. See how I do. I would add 6 to both sides, so I would get, negative 3x greater than or equal to 18. And then I would divide by negative 3. Now be careful here. Remember with inequalities, just to add one more crazy flipping thing to this, when you divide by a negative, your inequality needs to flip. So this is now going to say x is less than or equal to negative 6, or, and then when I come over here and solve this one, whoa, not at all what I meant to do. Don't worry about it. When I come over here and solve this one, I'm going to add 6 to both sides. So I get negative 3x is less than or equal to negative 6. Divide by negative 3, and again, when I divide by a negative, my inequality flips, so I would get x is greater than or equal to positive 2. So less than or equal to negative 6 or greater than or equal to 2. And again, that comes from our old rules on inequalities that said that when I multiply or divide by a negative, my inequality flips directions. Okay, to put that on a number line, this would be 2. This would be negative 6. These are going to be closed circles because I do have equal bars. And let's see, greater than 2 would go out to the right, and less than negative 6 would go out to the left. Okay? And so there would be your two possible ranges of numbers that would keep you more than 12 spaces away from 0. Okay, and let's go to that third one. So again with the third one, I will switch colors here so it doesn't blend in with the one above. With the third one, you've got to get rid of that other junk outside of the absolute value before you start. So I've got this negative 6 that needs to move and this minus 4 that needs to move. And just like I would in any other equation, I'm going to start with the minus 4. So I'm going to add 4 to each side so you can see what I'm doing here. So now I have negative 6 times the absolute value of x minus 4 is greater than, let's see, that would be negative 3. Okay. And then that negative 6 is attached with multiplication. There's really like multiplication between there. By the way, we never distribute an absolute value. We do not take this 6 and distribute. Okay, we are not multiplying this in here because this isn't part of the original absolute value. But I can get rid of it by dividing by negative 6 and dividing by negative 6. And so now I have absolute value of x minus 4 is greater than, and let's see, 3 over 6 is the same as 1/2 or 0.5. Either one's fine. Okay, so now we've got that set up to solve. I'm going to go over here and write my two separate inequalities. So I'm going to say x minus 4 is greater than 0.5. And again, this is an inequality with greater than, with absolute value. Greater than are the ones where you're pointing out to either side. Okay, it's you need to be further than this away, so it's starting at a number and heading out to the arrows. So these are the or ones. And so you would have x minus 4 could also be less than negative 0.5. All right, solve them both. Really just add 4 to both sides. So here I would have x is greater than 4.5. Or here where I add 4 to both sides, I get x is less than, let's see, 3.5. And so again, that would give me my range of numbers that are less than half a space away from 0. I'm sorry, greater than half a space away from 0. By the way, if you're stuck on the ands and the ors, if you're confused about when do we use and when do we use or, try not writing it in the beginning, okay? Try just setting up your two inequalities and solving them separately, and then look at them and decide, is it possible to be both at the same time? Is it possible to be bigger than 4.5 and less than 3.5 at the same time? If you can't be both, then it has to be an or, okay? If it's something like greater than 2 and less than 5, that is something that you could do both at the same time. It's the numbers in between, so that would be your and situation. Okay, and just real quick on a number line, what this is going to look like. I would expect, by the way, that your blank space on this one's going to be awfully tiny because you only need to stay half a space away from 0. Okay, so you only need half a space in each direction to be clear. We can choose any other number. So let's see, if we say that, let's go, here's 3, here's 4, here's 5. Greater than 4.5 is going to start here and shade to the right. And less than 3.5 is going to start here and shade to the left. So again, there's really only a very tiny range of numbers, and that would be these right here, that wouldn't serve as solutions here. Okay, because again, you only need to stay half a space away from 0, so that's not very hard to do. Okay, almost every number on the number line is half a space away from 0. So those are the types of things I would expect to see you doing when you're working through the inequalities, when you're working with absolute value and inequalities. Okay, and I'll just put this back up here and leave it for a second if you need to catch up on anything. And while you're doing that, you may also want to start copying down that next example. Okay, we're going to start talking about margin of error, but I'll give you a minute to jot that down. Okay, and I stole these numbers, by the way, from the most recent, I think it was from CNN, but I took these over the weekend. So as you know, by now, the actual Iowa caucus has happened. But they did this polling with voters in Iowa, and they looked at voters who were registered as Democrats and wanted to know how many of them would vote for Hillary Clinton in like a primary election. And they found that most likely 45% of Democrat registered voters would vote for Hillary Clinton, but that is with a plus or minus 4% margin of error. Okay, so here's what that means is their best estimate is 45%. That's what they're throwing out there on all the news stations is, she's at a 45% of the vote type situation. But it could be 4 points lower or 4 points higher. So if we go 4 points lower, that would be 41%, right? Or it could be 4 points higher at 49%. So the actual number that they're predicting would vote for her is somewhere between 41 and 49. And that becomes important because if they say that, Bernie Sanders is at 41% with a plus or minus 4, If Hillary comes down 4 and Bernie goes up 4, then Bernie may actually take the lead there. And so that's why these margins of error are important, and you'll hear them report like this is neck and neck, even though it looks like one number is higher than the other. If it's within the margin of error, and that's the terminology you'll hear a lot, if it's within the margin of error, that means that it's possible that their estimate is off just enough that one could overtake the other. And so virtually they're tied, even if one number looks higher than the other. So anyway, back to the math part of this. So we want to show this on a number line, and essentially we just did that up above, but here's my number line. I would go 41 is here. The highest it could be is 49. And again, I got that from adding 4 and subtracting 4 from what my actual estimate is. And then 45% would be somewhere right in the middle. And so we would know that actually somewhere between 41 and 49 is the actual number of voters that we're predicting would vote for her. You're going to learn a lot more about margin of error and making these predictions in AP statistics, by the way. So if you end up there for your senior year or even next year, you're going to learn about how this is all calculated. Okay, so now let's talk about how to write this as an absolute value in an inequality. And I will be honest, this is going to make it look more complicated than it needs to be. Because everybody can do this. Everybody can say, oh, if you go plus or minus 4, you go 4 this way, and there's your range. Okay? But you can express this with an absolute value. Because of this plus or minus 4, that's where the absolute value comes from, is I don't care if I'm 4 points up or 4 points down, I just know I'm within 4 spaces of my estimate. Okay, so that's what I'm really saying, is that the actual number of voters will be within 4 spaces of this 45, either in this direction or in this direction. Okay, so hopefully that's ringing a bell like absolute value. So here's what I'm going to do. The actual number that are going to vote for her is unknown. Okay, we have a range, but we're going to use A for the actual number, like when they do the voting, what percentage actually votes for her. Okay, and what we want to do is we want to know what's the difference between that actual and our predicted, which was the 45. Okay, and difference, hopefully that jumps out at you. Difference in math means subtract. Okay, and it actually doesn't matter which order you subtract here, but if I take my actual number of voters and subtract that 45% and find what's the difference between actual and predicted, okay, it should be within a range of 4 in either direction, meaning it could be up to positive 4 or to negative 4. And here's what I mean by that. If and you don't necessarily have to write this next little piece down, I just want you to see it. If they do the voting at the Iowa caucus and 47% vote for Hillary. Okay, so 47 minus 45 is 2. And that's within range of plus or minus 4%, right? Because that's less than 4 points above or below. If they do the voting and, let's see, 42% vote for her, 42 minus 45 is negative 3. Now, I don't really care that it's negative, okay, and that's where absolute value comes in. Is absolute value is used anytime you don't care about the negative. I just care that it's 3 points away from our prediction. Now, that's still within range. That's still within our plus or minus 4%, because that gives us 4 points of wiggle room on either side, and this is within that range, okay? However, if they do the voting and 39% vote for her, 39 minus 45 is negative 6. Again, because I don't care whether it's negative or positive, 6 points is outside of my margin of error. And so if that happened, we would say there was something wrong with our polling. But that's sort of where this is coming from. That plus or minus 4, I don't really care whether it's positive or negative. I just want to look at the difference. Okay? So here's how we set up an equation to show this. These numbers here that I was just kind of making up and saying, well, what if this happened? What if this happened? That's our A value that we talked about a minute ago. So that would be the actual number of voters. So I'm going to take the actual number of voters and subtract our prediction, which was 45. Okay, so actual minus predicted. Okay, and again, I don't care if it comes out positive or negative. If it comes out positive, that means that the actual was bigger than our predicted. If it comes out negative, our actual was less than predicted. But as long as it's plus or minus 4, I'm okay. So I don't really care if it comes out positive or negative, and that's why I'm going to throw absolute value brackets on there. Okay? And I want it to be within 4 points. So within should be telling you less than. I want to stay less than 4 points away from that prediction of 45. Less than or equal to 4. Because I want to stay within 4 points of this 45. And that's what this is doing for me, is it's saying that I want my actual number of voters to be within 4 points of this number. Okay? And so there's my inequality. If I went ahead and solved this, just like all the other examples we just did, I would end up with these two numbers that we had just talked about. So the 41% and the 49%. I would find that I need to be bigger than 41 and less than 49, which again, I feel like just about all of us could have told us that even just from the problem without having to write that inequality. But that's how you would express it with an inequality, because if you were an analyst and you were, analyzing your different margins of error and things like that, you would want to be able to work with an equation like that. Okay, so homework for tonight, just so you have an idea. There is a new worksheet that Mrs. Phillips will be handing out to you. And I believe it's just called Absolute Value Inequalities. Okay, this is all just solving. Oh, that should be a Q and not a G. This is all just solving and putting them on a number line. Okay, should be pretty straightforward. And then I also would like you to go back to last night's assignment. So that was the packet that I gave you that was copied out of the textbook. And I would like you to do the word problems from the first page. And gosh, I wish I had brought home a copy of that. But I don't know the problem numbers. It was like 47 to 51 maybe. It's whatever word problems were on that first page that I gave you. So yesterday we circled some that you needed to do. Today I would like you to go back and do the word problems that are similar to that margin of error problem we just did. So those two things plus Monday's assignment. So Mondays. By the way, if you weren't here yesterday, please see Mrs. Phillips or Mr. Brown, and they can get you set up with Monday stuff. All due tomorrow, so all due Wednesday, and we'll take questions on all of that stuff, and then we'll move on to some new stuff. So this is what I want you working on today. You do have the rest of the hour to work. Good luck.